Hi, welcome to Screencast 4.3, trig functions of the unit circle. So today we're going to be talking about when you have a circle with a radius of 1. So we're going to talk about a circle with a radius of 1, and then drawing triangles inside the circle to figure out the sine and cosine functions. So first off, I want you to look at this picture right here on your notes. So you notice that we have an initial ray and our terminal ray. So you would know that here the angle is more than 180 degrees. It is a positive angle because it's going counterclockwise. All right, so far we've been talking about what do we do when we have a triangle. Here's my x, here's my y, here's the hypotenuse of the side I care about, and then of course you have your x portion of this and you have your y portion of your triangle. So we have on a unit circle, the radius is going to be the length of our hypotenuse. So you can imagine that this is secretly a circle that goes all the way around, and the radius will always be the hypotenuse. So I could pick any point on my unit circle, and then I could draw a triangle corresponding to a certain degree, and the hypotenuse will be my radius. All right, so for this triangle, I have my theta that's being traced out from my initial, all right, so at the x position, x-axis all the way, so down here it was, probably close to 220 degrees. Here, up here with my example, I would say my angle is probably about 45 degrees. Awesome. So here, where we had an angle of 45 degrees, the point would have the coordinates of x comma y. So notice that, x is how far over we are, y is how far up. So if you have a unit circle with a radius of 1, the r will be 1, meaning if my sine would just be y over 1, whatever value my y is on my point. If you have a radius of 1, your sine will be your y. If you have a cosine, if you're trying to take cosine of this angle up here, you have x over r, so that's just doing, let's see, x cosine adjacent over hypotenuse. The adjacent of this angle is x, the hypotenuse is r. If you have a radius of 1, right, so if your hypotenuse is equal to 1, your x will just be your cosine theta. Your x will be the value of your cosine theta, and knowing this, tangent is normally equal to sine over cosine. Oops. Normally equal to sine over cosine. And I just told you, when our radius is equal to 1, my sine is equal to y and my cosine is equal to x. Cool. So up here, another way to write this point, if you have a unit circle, and unit circle means radius is equal to 1. And this could be whatever unit you want it to be, 1 meter, 1 inch, 1 foot. A unit circle just means 1. Unit is 1. A single unit is 1. So you could summarize this point by saying your point is going to be your cosine of theta, comma, sine of theta, because your cosine is equal to your x and your sine is equal to your y. Okay, so let's evaluate trig functions at a given point. Let -4, comma 3 be your point on the terminal side of an angle in standard position. So I'm going to draw this. Here's my x, here's my y. I need to draw, let's see, I go up 3. There's 3, go over 4, -4. So my point will be right here. And of course, this is the point on the terminal of an angle in standard position. Oops. So that's my terminal side. Here's my initial side. And this means that my angle goes all the way over. Cool. So I need to figure out what would be the exact values of the 6 trig functions of theta. So I need to label my triangle. So whenever you have an angle that's above 90 degrees, you have to make the angle between your terminal side and the x-axis. So it's called a reference angle. So I'm going to be looking right here. I'll draw this triangle out for you. This is going to be my theta. This has a value of -4. The height, right? So the height, the y value is 3. The x value is -4. And I need to find my hypotenuse. So let's try to figure it out. So I can do 3 squared, because remember this is a 90-degree angle. I can use Pythagorean theorem, times -4 squared. You may already recognize this is a 3, 4, 5 triangle. If you don't, do not worry. 9 plus 16 is equal to 25. Square root of 25 is 5. Cool. So we know this is 5. So we have hypotenuse equal to 5, adjacent equal to -4, and our opposite side is going to be equal to 3. So let's go ahead and let's find the 6 standard positions, and we want the exact values. We need the exact values. So sine of theta, so this is just a review of what we've done so far. SOHCAHTOA. Sine is opposite, 3, over hypotenuse 5, 3/5. Cosine theta is adjacent over hypotenuse. The adjacent's -4. Hypotenuse is 5. And tangent of theta is going to be equal to opposite, 3, over adjacent, -4. So if you look from up above, let's make sure this matches what we just remembered. So my sine should be y over r. Let's double check. My y value is 3. Cool. And we found the radius is 5. So this matches what we did. Cosine theta, you know, is x over r. So our x value here is -4. Our r is 5, -4/5. And then tangent, we said, was y over x. The y was 3, right? Y was 3. X was -4, so -3/4. And then when we do the reciprocal functions, remember reciprocal is we just flip whatever's on top and bottom, just flips. So cosecant of theta, this would be radius over y, so 5/3. Secant is the inverse, so we flip what was on top and bottom, so 5 and -4. Secant, and then we have cotangent of theta. So we flip, we have x over y, my x was -4, my y was 3, and this matches, it's opposite of what tangent was. So, when the terminal side of an angle in standard position lies on one of the axes, when the terminal side is on one of the axes, the initial side is always on this axis that I just highlighted. It's always on the x-axis. But when the terminal side's on one of the axes, it's called a quadrangle angle. I don't know how to say it, but clearly it has to do with 4 because quad means 4. So the first one I'm going to talk about is the one where the terminal side is on the same side as the initial. So here we see that, let's see, sine of 0 degrees. So sine is going to be equal to y over r. So y over r. Here, there's no y value, right? Because remember, x comma y is how you write a point. So if our x comma y, the second value is 0, that means it's going to be 0 over r, so 0 degrees, so 0. Sine of 0 is 0. Cosine of 0 is going to be x over r. So my x value is r. Here, my, r value is r. So you can see that, well, that simplifies to 1. And that's true. Cosine of 0 degrees is equal to 1. No matter what your radius is, cosine of 0 is always 1. Tangent of theta is going to be, let's see, we said it was going to be y over x or sine over cosine. So y over x, which is the same thing as saying sine over cosine. So the y value was 0. Remember, right here, the y value is 0. The x is r. The x value is literally just our radius right here, our x value. So that's going to equal 0. So if we try to find the reciprocal angles, so cosecant of theta, well, we flip it, so we'll have r over 0, and that's going to be undefined. You can't divide by 0. The reciprocal function of cosine is secant of theta. So here, if you flip r over r, you still get r over r is equal to 1. The reciprocal of 1 is 1. And lastly, we have cotangent of 0 degrees. So cotangent, we flip it, so we'll have r over 0. Because remember, cotangent is the flipping of the tangent. So you have x over y, which is our x value is our radius, our y is 0. So here, once again, it's undefined. And this is for theta equal to 0 degrees. Cool. So the next one is going to be, oh dear, I ran out of room. So I'm going to do this one, 90 degrees. I'll write a little smaller. So let's go again. So sine of 90 degrees. Because remember, these are the quadrangle angles. So my terminal side is now going to lie on the positive section of my y-axis. So sine of 90 degrees is equal to y over r. Here, my xy coordinates are 0 and r. So my y value is going to be the radius. We go as high as the radius allows us to. Here, the radius just means the length of our coterminal ray. So r over r, yeah, so that makes sense. Sine of 90 degrees is equal to 1. Let's try cosine of 90 degrees. This is going to be x over r. And since our x is equal to 0, our cosine of 90 degrees will equal 0. Tangent of theta is equal to y over x. Y over x. So our y value is r, our x is 0. This is going to be undefined. And you already know this from trig. Tangent of 90 degrees is undefined. Oops, tangent of 90. So let's go through, let's find the reciprocal functions. Cosecant of 90 degrees is going to be 1 over 1, right? So I just flipped it, that's equal to 0. I'm sorry, that's equal to 1. Ugh, simplifying. Secant is the reciprocal function of cosine. So secant of this angle is going to be r over x. So once again, that's just r over 0, so that's undefined. And then cotangent of 90 degrees is going to be equal to x over y. Here, our x value is 0, because remember, this is for 90 degrees. Our x value is 0, and our y is r. So we get a cotangent of 0. So notice that when you have 0 on one of the sides, the reciprocal is going to be undefined, because then you'll be dividing by 0. So you see that here and here. Awesome. All right, so the next one, these last two are very similar to the first two I talked about. The difference is when you have a degree of 180, your terminal angle, your terminal side is still on the x-axis. It's just on the completely different side. So instead of having positive r comma 0, you have negative r comma 0. So everything is going to be the exact same, except instead of having, the negative r here doesn't change it 0, but here you would, instead of having a positive 1, you'd have a negative 1 for cosine, and instead of having a positive 1 for secant, you'd have a negative 1 for secant. That's the main difference. Your cosine of 180 degrees will be negative 1, which means the reciprocal function, secant of 180, will also be negative 1. Otherwise, everything else is the same. You still don't have a height. You still don't have a y value, right? Because it's going to be 0. So your sine is still 0, your tangent is still 0, and your cosecant and cotangent are still undefined because you're dividing by 0. Lastly, if you have an angle of 270 degrees, it's going to be similar to the 90 degree. All right, so here's my coterminal angle. We go all the way around. So this is negative 270 or 3 pi over 2 radians. Notice the difference between the 90 degree and 270 is we have a positive 0, comma r for 90, and we have a positive 0 and a negative r. So once again, I just have to go through my 90 degree angles and just make my r negative. So my sine of theta, sine of 270 is equal to negative 1. And you can see that, right? Like you see the height is negative. It's going down. And that makes my cosecant also negative. So cosecant of 270 is going to be negative 1. Otherwise, dividing by 0 doesn't matter if your radius is negative. It will still be undefined. And taking 0 dividing by a negative number is still going to give 0. Same way here, taking 0 instead of dividing by positive, dividing by negative, you still have 0. Over here, still dividing by 0, still get undefined. Okay. So let's try to find the exact value of each trig function. So cosine of pi. So let's draw a small little xy. So here's my initial, and pi goes all the way around. So here is my final. So, okay, cosine of pi, cosine is x over r. I know that my radius, well, when we're not told, we can assume the radius is equal to 1. Thank you to our unit circle. So my x value is going to be negative 1, and then my radius is still 1. So why is the x value negative 1? Because we are on the left side of our x-axis, we're in the negative portion, and when we don't know the value, like when we don't know how long our ray should be, our terminal ray, we will assume it has a unit value, which is 1. So our cosine of pi is equal to negative 1. Okay, now let's try tangent of 450 degrees. So I'm going to try this out. So here's my x, here's my y. Here's my initial ray, and then let's see, 450 is more than 360. So I'm going to go all the way around 1, so now I'm at 360. I still have 90 more degrees to go, so I go all the way to here. So my terminal is right here, so I'm just going to put T for terminal so we know where it is. So I am at a point of 0, 1. I am one unit high. And so tangent of 450, tangent is just y over x. So this y value is positive 1. The x is 0. Well, you can't divide by 0, so it's going to be undefined. Lastly, we have cotangent of 7 pi over 2. So I'm just going to quickly write that as an improper fraction. So that'll be equal to 7, let's see, 7 second pi is equal to 3.5 pi. X, y, here's my initial, and then let's see, so I'm going to go around, here's 2 pi, 3 pi, because ready, here's 1, 2, 3 pi, and a half. So I end up right here. So this is my terminal side. This is my terminal side. So I am at a position of negative 1, 0. No, wait. Sorry, x, then y. So I'm at 0, negative 1. X, then y. Alright, so cotangent of 7 pi over 2. So cotangent is going to be x over y. So my x value is 0, my y is negative 1. So it's going to be equal to 0. So just to review, so when you have to find the exact value of each function, you can draw triangles as long as the hypotenuse is equal to 1. That's the whole point of the unit circle. I highly recommend reading the section before you go over these notes. So that's why we have the book. And just in general, so there's going to be 4 points with the quadrangle angles or whatever. So we have the positive 1, 0, which is going to be 0 degrees or 0 pi. We have positive 0, 1. All right, so you just go 1 up. So this is going to be your 90 degrees or pi over 2. We have negative 1 comma 0, so that's going to be pi or 180 degrees. And then down here we have 0 comma negative 1, so that's your 3 pi over 2 or 270 degrees. So all of these have a radius of 1, right? So you'll always be like 1 over from the origin, or 1 up or 1 down from the origin. Okay, so a reference angle may be used to evaluate trig functions of any angle which are neither acute nor quadrangle. So to be clear, the reference angle is going to be the acute angle between the terminal side of the angle and the x-axis. So in our first quadrant, it's pretty simple because here's the terminal and here's the x-axis, and clearly the angle, our reference angle, is just going to be equal to our angle as long as it's less than 90 degrees, aka in quadrant 1. However, if we have a terminal side that's in quadrant 2, our actual angle, for instance, this one is 160 degrees. Well, that's really a big number. You don't know that off the top of your head. So the reference angle that we're interested in is between the terminal side and the x-axis. So terminal side and the x-axis. So here, how do I find my reference angle? How do I find my theta? Well, I know that this total, the total degrees from the initial all the way over to the other side of the x-axis is going to be 180. Remember, here this angle would be 180 degrees. So together, 160 plus whatever my reference angle will be is going to equal 180. Subtract 160 on both sides. You find that this reference angle is going to be 20 degrees. So that is what this means right here. The difference is, if I just subtract my angle from both sides, I have my reference angle is equal to 180 minus whatever my theta is. That's all this is saying. And of course, it's the same thing when you work with radians. So in quadrant 3, here is my initial ray, here's my terminal side, and to get my reference angle, aka if you're going to evaluate trig functions and your angle is greater than 90 degrees, right? It's not between 0 and 90, you have to use reference angles. So in quadrant 1, it's pretty easy. You just have the basic triangle we've been learning. But in the example I just did with quadrant 2, you have to use this triangle. Right? So what you're really looking at is between your terminal side and your x-axis. Over here, it doesn't matter what the angle is. It's between your terminal side and the x-axis. You can have this really shallow. Terminal side, x-axis, this would be your triangle. And then let's just have this 45. Terminal side, x-axis, so it's the angle here. These would be the triangles you use to solve for your trig functions. And let's just keep going through this. Okay, so for quadrant 3, here's your initial, here's your terminal, your angle goes all the way over, except this is over 90 degrees. This is actually a 210 degree angle. So in order to find the trig functions of this 210 degrees, we're going to use this reference angle right here. So what we can do is, once again, this is just the flipped version of quadrant 2. So between the origin, your initial ray, and the other side is 180. Except here, I am going to, it's just the opposite of what I did with quadrant 2. Since if I subtract 180 from this theta, I'll get whatever this reference angle is here. Since we don't know the reference angle, and we don't know what this angle is right here, we can't just do 180 minus reference angle, but I do know what the total angle is from the initial all the way over to the terminal. That's 210. So if I take 210 minus 180, I can figure out that this reference angle right here is going to be 30 degrees. And then, 30 plus 1 is equal to 180. Then we would find out that, oh, okay, this other side that we had no clue about is 150. That's not important. That's just knowing that we can't use, 180 minus reference angle, because we don't know the reference angle, so we don't know this other side, but we do know the top. The top's 210, so if I subtract all of this 180, what's left over will be my reference angle. And lastly, if we're in quadrant 4, here's my initial side, here's my terminal side. Let's follow this all the way around. So I know that this is about 310 degrees. What would this angle be right here? Well, this is the angle literally between terminal and initial if I would went negative. Instead of positive 310, if I would just done the negative co-terminal angle, that would literally be what it is. Well, I know total, my 310 degree angle plus my reference angle is going to have to be 360, because look, it goes all the way around, whether I'm with the pink or this gray, it's going to equal 360. So I can just subtract whatever my angle is. So I have 360 minus whatever my original angle is going to be equal to my reference. So here, 360 minus 310 is going to give me an angle of 50 degrees. Okay, so let's try example 2. Sketch each angle and find its reference angle. All right, so here's my x, y. Just set this up, x, y. All right, so my initial, of course, always goes along this x-axis. Negative 150. Let's see. So negative means it's going to be going clockwise. And I know if I go down this way, that's 90. So I have 60 more degrees to go, so it's going to be around here. T for terminal, I for initial. There. So this is negative 150 degrees. How did I know where to go? So I know that right here is a 90 degree angle, and I needed 60 more over here. Okay, that's just a little side. Okay, so we sketch each angle, check, and find its reference. So how do I find the reference? So remember, the reference angle is going to be the angle between the terminal side and the x-axis. So here is my terminal side. Here's the x-axis. Hey, look, they meet at this one vertex point right here. That's going to be my theta naught, whatever. So this is the angle I'm interested in. Reference angles are always between your terminal and your x-axis. You can kind of think of this as a butterfly. Of course, God, that's really ugly up here. So you can kind of think of it like making a butterfly. It's going to be between your terminal and your x-axis, between the terminal and x-axis. So the triangles you'll ever use, you're always going to make them with the x-axis. And that wasn't clear when I was going through school, but try to make sure that's clear to you, always between terminal, x-axis, terminal, x-axis. Because ideally, we just want to do the trig with angles between 0 and 90, because you know the angles between 0 and 90. That way, you don't have to learn 16 different angles, you would just have to learn like 4, right? 30, 45, 60, 0, 90. There you go, 5 angles. And then if you can tell if you're positive or negative on the x or y, then you'll automatically understand 16 different angles. Anyway, so how do I find this angle right here? Well, I know total. I know if I add these together, they have to equal 180. So total, they have to equal 180. I know this is the complementary, these two angles, right? My theta plus 150. Here, I don't care if it's positive or negative because the negative just says, hey, from the initial. What I'm interested in is knowing here, this 150 degree plus whatever this degree is here is going to equal 180, subtract 150 on both sides, and I find that this angle is going to be 30 degrees. So here, that's a 30-degree angle. All right, so I have 3 pi over 4. How do I do this? So I know that over here is pi, so if I would have 4/4 pi, I would go all the way around, but I'm not. And I know a 90-degree angle right here would be pi over 2, which is equal to 2 pi over 4. So this is 4/4 pi. My bad, so ugly. So it's 4/4 pi, here's 2/4 pi. So it's going to be right in between. And this is positive, so I go for my initial counterclockwise since it's positive. All right, there's my terminal side. I'm just gonna label this terminal. And we need to find its reference angle. So between the terminal and the x-axis. So you kind of see where the angle will be if you trace it out, because you're like, oh, here's the vertex. It's gonna be this angle right here. So I know, let's see, 3 pi over 4 plus whatever this angle is going to equal 4/4 pi. So it's going to equal 1 pi. Subtract 3/4 pi on both sides. You find that our angle is going to equal pi over 4. And that makes sense because here's like 1/4 pi, 2/4 pi, 3/4 pi, 4/4, which is going to be 1 whole pi. Okay, cool. So we found that this is equal to pi over 4. Let's keep going. So evaluating trig functions at any angle. This literally means you found the reference angle. Now, how do we actually find the value of the trig function? All right, so you did the hard part already. You found this angle. And that's step 1. Step 1 is you have to find the reference angle of theta, and you know that this is going to be between the terminal side and x-axis. So that's the angle between them. And I think that's where people get messed up the most. Once you have this, I feel like the rest is sailing. Not smooth sailing, but it's way easier. All right, so step 2 says, find the value of the trig function for theta. So for our reference angle, we want to find the value of the trig function. And then, using the quadrant in which the terminal side of theta lies, determine the sign of the trig function. So if you remember, all students take calculus. That's how you know the sign. So you start the first quadrant and just follow the number of the quadrant. All students take calculus. So in the first quadrant, all of them are positive. In the second, sine's positive, S. Third quadrant, tangent's positive. Fourth quadrant, cosine's positive. So that tells you what's positive in each quadrant. First quadrant, all of them. So all students take calculus. All right, let's do this. So example 3 says find the exact value of each expression. So how do we do this? First, we want to find the reference angle. So let's draw our picture. Here's my initial. Let's see, 120 is more than 90. So I have 30 more degrees. It will be something like this. Oh, it's not straight. Whatever. Terminal side, initial side. Let me draw the arrow so I know which way I went. Okay, so I've drawn it. And now I want to find the reference angle. So remember, it's between the terminal side and the x-axis. So this is going to be my reference angle. So in order to find my reference angle, let's see, so 120 degrees. So 180 will equal 120 plus whatever this reference angle was. Subtract 120 on both sides. 60 is going to be our reference angle. Okay, so we have reference angle of 60. And we know in this quadrant, quadrant 2, sine will be positive, cosine will be negative. All right, because we have at this point, oh my gosh, because at this point right here, right, that's going to have a negative x value and a positive y. Does that make sense? We're going to have a positive sine and a negative cosine. Okay, so we found the reference angle. So now we want to do cosine of 60 degrees. What does that equal to? How can we do this? Well, you have all the tools in your toolbox. So let's just draw a triangle. So when we have a 30, 60, 90 triangle, those have special values. So I could say the hypotenuse is 1. That would make this adjacent side equal to 1/2, and this over here square root of 3 over 2. Because remember, 1 squared is going to equal, oh my gosh, we're in a room. Because if I do Pythagorean theorem, let's see, 1 squared should equal square root of 3 over 2 squared plus 1/2 squared, so it's equal to 1, equal to 3 over 4 plus 1 over 4, which is equal to 1. Cool. If you don't automatically remember this, it's okay. I gave this to you a couple pages back, all the trig values for the two special triangles 45, 45, 90 and 30, 60, 90. Either way, we could figure it out. All right, so cosine, let's see, cosine is adjacent over hypotenuse, so 1/2, sorry, here's 60. So adjacent is going to be 1/2, hypotenuse 1, let's go ahead and plug that in. So cosine of 60 is equal to 1/2 divided by 1, so that's just positive 1/2. And as I said before, we are in the second quadrant, which makes our value negative. So cosine of 120 is going to equal to 160, except it's going to be negative. All right, let's do another example to understand. All right, so 4 pi over 3. So this is going to be more than 1. So this is going to be 1 and 1/3 pi. So this tells you right away that, okay, here's our initial. So we're going to go all the way to pi and then 1/3 the way back. It's not very nice looking. Okay, so that is 4/3 over pi. 4 pi over 3. Oh my gosh, 4/3 pi. So let's see. We need to find the reference angle first. So reference angle is between terminal and the x. So what will this angle be? Well, we kind of figured it out already, because going over this far is 1 pi, and then the continuation is 1/3 pi. Or you could say pi over 3 is going to be our reference angle. Okay, well, what is sine of pi over 3? Lucky for me, I've already drawn the triangle for this, because pi over 3 is going to be 180 over 3, so that's 60 degrees. So I'm using my 60-degree angle, except this time I'm using sine. So that's opposite over hypotenuse. So the opposite is square root of 3 over 2 over 1. So this just gives me square root of 3 over 2. Sorry if that was a little fast. So just remember, so right, opposite over hypotenuse. Pi over 3 I found right here. Come on. Found pi over 3 is equal to 60. Here's my 60-degree angle. And so I'm using opposite over hypotenuse. Square root of 3 over 2 divided by 1 is just square root of 3 over 2. Okay, so we found the value using our reference angle. So now we got to plug back in our original. So 4 pi over 3. So in the third quadrant, let's see, all students take calculus. Oh my gosh. So in the third quadrant, tangent's positive, which means we'll have a negative value for our sine of 4/3 over pi. So it just makes it negative. Last one. Whew. All right, secant of 15 pi over 4. Let's go ahead and draw that. Here's my initial. All right, so 15 pi over 4. Let's see, 15 pi, let's simplify this. So this is going to be equal to 3 and 3/4 pi. So that means we're going to go all the way around once. Let's see, so we're going to go all the way around once. And then we're going to go, so that's 2 pi, 3 pi, 3.5, 3/4 pi right there. All right, because this was the first time around was 2 pi, and then 3 pi, so 1, 2, 3 pi, 3.5 pi, 3/4 pi. Okay, 3 and 3/4 pi. All right, and remember we, let's see, we had to go, it was a positive angle, so we had to go counterclockwise, just making sure. So lastly, let's find our reference angle. So that's going to be this guy right here. Here's our reference angle. So how do I know what this angle will be? I mean, I kind of told you already, right? So we did 2 pi, and here's 3 pi, and now this last part from this axis to this one has to equal pi. And so I know that this was a 3/4. So I have 3/4 pi plus whatever this angle is going to equal pi. Because the total, so it's basically 180. 180 is pi. So if I subtract 3/4 pi on both sides, I will get pi over 4. That is my angle, pi over 4. So this is a 45-45 triangle. How do I know that? Let's see, pi over 4 is 180 over 4. And that's equal to 45. So I have a 45-45-90 triangle. 45-45. So if I make this side length and this side length 1, let's see, 1 squared is 1. So 1 plus 1 is equal to 2, and then you have to square root it to find the hypotenuse length. So I have 2 is equal to, well, let's see, squared. So when you like square root it, that's how the hypotenuse turns into square root of 2. Okay, so secant is equal, let's see, it's the inverse of cosine. Cosine is adjacent over hypotenuse, so this secant will be hypotenuse over adjacent. So hypotenuse square root of 2 over 1. So let's go ahead and do that. Secant of pi over 4 is equal to hypotenuse, which is square root of 2 over 1. So that's just square root of 2. Let's see. So that's what secant of square root of 2 is. When we plug back into our actual value, 15 pi over 4, we know that square root of 2 will be there. Question is it positive or negative? Well, let's see, is cosine positive or negative? Is cosine positive or negative in this fourth quadrant? Aha, it's positive, which means if you do the reciprocal, it's still going to be positive, so it's just square root of 2. Okay, and we're almost done. So use one trig value to find others. So example 4, let secant of theta equal square root of 29 over 5. And where sine of theta is greater than 1, find the exact values of the remaining 5 trig values. So let's figure out where we are. Oh, did not mean to do that. How did I do that? Okay, so if we draw our xy, where is sine positive? Well, sine is our y value, right? So remember, sine of theta stands for y. It's going to be our vertical. So sine of y is positive here. Let's see, sine is positive here. Sine is positive here. So that takes care of it greater than 0. And then secant is secant's positive. Remember, secant is the reciprocal function of cosine. So if that's positive, cosine has to be positive. And remember, cosine is just our x value. So where is x positive? Cosine's positive here. Oops, positive. Cosine's positive here. So really, the quadrant we're looking at is quadrant 1. That's the only place where they overlap. That's the only place where sine and cosine are both positive. Okay, cool. So now we know where we are. We can draw our triangle and then figure out the rest of the functions. So we're going to be in, let's see, the angle is in quadrant 1. Quad 1. Oops, that's not theta. So angle's in quadrant 1, so the next thing we're going to do is we're going to draw a triangle. So let's see. So here's my theta. All right, secant is equal to 1 over cosine. Remember, cosine is adjacent over hypotenuse, which means secant is going to be hypotenuse over adjacent. So this square root of 29 is my hypotenuse. And my adjacent is going to be 5, right? The bottom adjacent is 5. So let's figure out what this other side would be. So we have square root of 29 squared is equal to 5 squared plus, I'm just going to put y since this is the y value, y squared. So the square root of a squared square root just cancels out. Okay. 29 is equal to 25 plus y squared. Subtract 25 on both sides. 4 is equal to y squared. Hey, look, this is going to equal to 2. All right, so we solved our triangle. Now what we want to do is find the remaining functions. I'm just going to list them out. So we have sine of theta is going to equal, let's see, so opposite over hypotenuse, opposite 2 over hypotenuse 29, square root of 29. Don't like radicals being at the bottom. So let's go ahead and let's multiply by 1, just a clever form of 1. 2 times the square root of 29 over 29. Cool. Next, cosine. Well, cosine is just the reciprocal function of secant. But we also could look, all right, so let's see, so cot-TOA, the adjacent, which is 5, over hypotenuse 29, so it'll just be 5 over square root 29, once again, multiplied by this clever form of 1. That's just to get rid of the radical. 5 square root 29 over 29. Tangent. So tangent is TOA, opposite over adjacent. Opposite 2 over adjacent 5. Cool. Let's see, so we have 2 more functions to find. So let's see, I already know secant. I'm just going to write that. I know secant square root of 29 over 5. So we're just writing the opposite ones, the reciprocal. So let's see, cotangent will be pretty simple. You just flip it. Instead of 2/5, we have 5 over 2. And then cosecant, I'm going to go back to our original right here. That way I don't have to do all this magic. You just flip it, so that way we have square root of 29 over 2. Cool. So that's how we found it. The hardest part was knowing to draw the triangle and knowing which quadrant we were in, so knowing where sine is positive and where cosine is positive. So if you can just remember that sine is your y, cosine is your x, it makes it much, much simpler. All right, so the unit circle I've been alluding to is a circle with a radius of 1 centered at the origin. So the measure of an angle is equal to s over 1. So that's just going to be the arc length over 1. So thus the arc length intercepted is going to be the same as the angle measure in radians. Because if you remember this, all this theta is your definition of radian. Before we said it's the arc length over radius, but if your radius is 1, your measure in radians is just going to be your arc length if this bottom part is equal to 1. So you will need to know this coming up pretty soon. It's very useful, but as I was saying before, if you know these 5 values, 0, 30 degrees, 45, 60, 90, you'll automatically know all the rest. And why I say that is I told you about all students take calculus. So if you look at the x value of pi over 6 and negative pi over 6, actually all of the x values on the positive side are going to be equal, and then you just notice the y is flipped. So that's what I was alluding to up here with all students take calculus. All of the numbers, the numbery part, are going to be the same everywhere. It's going to be the signs that flip. So here you see we have a positive value. Over here it's positive because this is the y value, but then on the bottom you see it turns into negatives. So this looks very intimidating, but if you can learn these and then understand that all students take calculus, you'll remember what's positive and negative here. If you also understand that cosine of theta is your x, and sine of theta is your y, it also makes it simpler because you're like, well, at pi over 6, you draw your triangle, and you know this will be 1, and this is a 30 degree. Like you can figure out these yourself. All right, let's keep going. So find the exact value of each expression. So key here to solving these is you can use the unit circle. So you can use the unit circle. So for instance, let's do the first one, sine of 7 pi over 6. So I know, let's see, so katoa. Sine is opposite over hypotenuse. Opposite over hypotenuse. So 7 pi over 6. Here's my 7 pi over 6. So here would be the terminal angle, like if it was going all the way around. And so if I would want to find my reference angle, it would be this one right here, between the terminal side and the x-axis. Well, I can draw a triangle to solve this. So here's my triangle with my theta. So my x value is negative square root of 3 over 2. My hypotenuse is 1 because it's a unit circle, radius of the circle is 1, and my y value is negative 1/2. So using SOHCAHTOA, opposite, negative 1/2 over hypotenuse of 1. So that's negative 1/2 over hypotenuse of 1, so it's just going to be negative 1/2. So I'm using my y and x values on my unit circle. So I can try this next one. So cosine of 5 pi over 4. Let's see, 5 pi over 4. So that would be 1 and 1/4 pi, so it's right here. So this tells you, let's see, so I'm just going to draw the triangle over here. So here's my theta, 5 pi over 4, because this would be the x-axis and the terminal side for my 5 pi over 4. Notice the x and y are the same thing, square root of 2 over 2, negative square root of 2 over 2. Kind of makes sense here in the third quadrant. X and y are both negative. So I'm doing cosine. Cosine is adjacent over, of course, the hypotenuse is 1. So this would be negative square root of 2 over 1, which just simplifies to negative square root of 2 over 2. Negative square root of 2 over 2. Cool. So the key here is, like, we're finding a reference angle and then we're solving for that angle. So here, notice how I'm using this angle, not the whole one. Here I'm using this angle, not the whole going all the way around to 5 pi over 4. I could draw a circle for you, show you what I mean. Here's a circle. Let's see. So 5 pi over 4. Here's pi, and then 5 pi over 4 would be right here. And so then I'm looking at this part, and that is the triangle I'm using. We're inside here. That angle is pi over 4. And then after I plug in pi over 4, cosine pi over 4, I know that over here my cosine value is negative. So that's why, like, that's how you can justify putting the negative value there. So if you know these functions right here, you know their values, you can solve for any of the other functions, all these others. Just knowing whether or not it's going to be a positive or negative x or y value depending on where you are on which quadrant. All right, tangent of 11 pi over 6. Let's see, 11 pi over 6. Let's go ahead and find that one. 11 pi over 6 is right here. So here would be right here. Here's our theta. So I'm using a triangle that looks like that. Let me plug in the values. So my x is going to be positive. Okay, my x is, here's my x, square root of 3 over 2. My y is negative, because it's below the y-axis, negative 1/2, and of course my hypotenuse is 1. So tangent is opposite over adjacent. So opposite of negative 1/2, this is going to be a little ugly. All right, opposite, negative 1/2 over adjacent of square root of 3 over 2. Let's see, the 2's cancel out, and I have negative 1 over square root of 3. That doesn't fly, gotta multiply by 1, just get rid of the radicand. So negative square root of 3 over 3. All right, so that's one way of doing it, is just looking at your unit circle, but let's try what we've been practicing. Here's the unit circle. All right, here's x, y. So I'm going, here's 6/6 pi, because I go around once. So literally I want to divide this into, let's see, I'm trying to divide this into 6 equal parts. So this would be, let's see, 11 6 pi is not all the way around. This is how you can justify if you don't have the unit circle. Let's see, it's 7, 8, 9, 10, 11. Haha, here's 11 6 pi. Right there. Alright, 11 6 pi. So let's go ahead and let's find our reference angle right here. Well, you can see that it would be 2 pi minus 11, let's see, 11 pi over 6. So that's 12 pi over 6 minus 11 pi over 6. It just made us, them have the same denominator. So then I get a reference angle of pi over 6. So if you do tangent of pi over 6, what do you get? Let's see, so I have this triangle right here, where I know this angle. Let's see, pi over 6. You guys, you think it's easier in degrees, that's totally fine. Pi over 6, let's see, I want to convert. To degrees. 6, 30, cancel out. Okay, 30 degrees. So this is the 30 degree. And so you already know 30, 60, 90 triangle, how to lay it out. So this is the 60. So we can have, let's see, hypotenuse of 1. Across from the 30 is going to be the half, and then up above, adjacent to the 30 is square root of 3 over 2. The way I remember that is I know the 3 values of 30, 60, 90 triangle are 1, 1/2, and then square root of 3 over 2. Which angle is smaller? 30, well, the smaller angle will have the smaller side length. 1/2 is smaller than square root of 3 over 2. Half is across from 30 degrees. Oops, this is the 90. So the angle we're interested in, 30 degrees. Okay, so let's find tangent 30. Tangent, opposite over adjacent, opposite, 1/2 over adjacent, square root of 3 over 2. This gives me 1 over square root of 3. And of course, simplify that, get the radicand out. It's the exact same thing I did up here. So 3 over square root of 3. Difference is, let's see, all students take calculus. Over here, cosine's the only positive, which makes sense because tangent is sine over cosine. If sine is negative, all of tangent will be negative. So that's how we get this last negative in there. And look, we get the same answer. So I want you to use your unit circle a little bit so you can get comfortable, but I also really want you to take this to heart, the reference angle, because that's going to be key for the rest of the unit. All right, secant of 270. So 270 is one of our special quadrant functions. Good Lord, I don't know how to say this. X, Y, here's my initial, 90, 180, 270, right here. Okay, so I know this point, which way will you go to make your triangle? It's a special one. You can't make the triangle, your triangle, the angle you'd be interested in is 90. Weird. Let's just write down our X and Y values. So our X value is 0, Y is -1. Secant of 270. If I look at the inverse, let's see, inverse of secant is cosine. So cosine is going to be my X value. This is way, way from the beginning. It's literally cosine is my X over my R. Of course, my R is 1. And which means secant is going to be the reciprocal of that. So it'd be R over X. My radius, of course, I am 1 away from the center point, but then my X is 0, undefined, because can't divide by 0. Okay, cool. We are almost done. All right, so the periodic nature of circular functions. I apologize, this is so long. I'm just trying to make sure you really understand this. Watch this on YouTube, twice speed, I don't care. Find the exact value of each expression. All right, so let's simplify this out a little bit. So 9/4 is equal to 2 and 1/4 pi. So that's going all the way around once and then just going up a pi, or a fourth. So go all the way around once and then up a fourth. So clearly, like, this angle we're interested in is just pi over 4. Pi over 4, hey, that looks really special. That's a 45, 45, 90 triangle. 45, 45, 90. So these are the same. So you have 1, square root of 2 over 2, square root of 2 over 2. Yep. Cool, square root of 2 over 2. So if we want to do cosine, let's see. Adjacent over hypotenuse, square root of 2 over 2 over hypotenuse 1. You get square root of 2 over 2. Cool. B, negative 300 degrees. So negative would mean you're going down. So this is negative 270 and plus the 30 right here. So that's how I know how far to go. So this is negative 300 degrees. I need to find my reference angle. Well, I know the total degrees in a circle is 360. If I've gone 300, this angle has to equal 60 degrees. So let's go ahead, let's find sine of 60 degrees. Let me draw out the triangle so we can remember. So this angle here is going to be 60, it's what I'm interested in. Here's the 30, and remember opposite of 30 is the smaller one, 1/2. Opposite 60 is square root of 3 over 2. And then of course there's a 1 for the hypotenuse. So opposite over hypotenuse. Opposite, square root of 3 over 2 over hypotenuse 1. So this is just going to be square root of 3 over 2. Awesome. And since, our sine value, since we're in the first quadrant, I know my sine value is going to be positive. It doesn't matter when I put in sine of negative 300. I'm still in this terminal side is in the positive. It's in the first quadrant. This is in the first quadrant, so I know I have a positive. So when I plug in, like when I go to rewrite cosine of 9 pi over 4, it doesn't change the answer because it's still in the positive quadrant. I go to type in sine of negative 300 degrees. It's still in the positive first quadrant, so it doesn't change it. All right, last one. Tangent of 29 pi over 6. Oh my gosh, okay. 29 pi over 6 is the same thing as saying 4 and 5/6 pi. Okay, so the 4 pi would mean going around twice. So let me show that. Here's my initial. All right, so here's 1 time around, so it's 2 pi, 4 pi, and then 5/6 pi. So that would be, let's see, here's 4.5. So 4.5 pi, let's see, 4 and 3 pi over 6, that's 4.5. 2, 6, so we have to go about right there. Because that's about half, maybe a little bit less. Okay. Let me draw my terminal side. Okay. So right here, that's 4 and 6 pi. So I could think of this as 5 pi over 6, because technically going around twice takes into account the 4 pi, because each time around is 2 pi. So the angle I'm interested in is right here, this angle. So I know together the 5 pi over 6 plus whatever my reference angle is going to equal pi. So to solve for it, you just take pi minus 5 pi over 6, you get the angle is pi over 6. So let's try to find tangent of pi over 6. Wait, pi over 6, let me convert that to degrees. Maybe we know this one. So pi over 6 multiplied by 180 over pi. Pi's cancel out. 180 divided by 6 is 30 degrees. Hey, I drew this up here. So I'm interested in tangent of 30 degrees. So here's my 30 degrees. So I want tangent of 30 degrees. TOA, let's see, opposite, 1/2 over adjacent, square root of 3 over 2. Well, the 2's cancel out, or I can show you this, hold on. So 1/2 divided by square root of 3 over 2. Multiplying by a fraction is the same thing as, dividing by a fraction, same thing as multiplying by a reciprocal. 2's cancel out. That's what I mean when I say 2's cancel out. Dividing by the same thing. So I get 1 over square root of 3. Of course, that's ugly, but ugly. Okay, cancel it out, multiply by 1. Square root of 3 over 3. Question is this positive or negative? Bum, bum, bum. All right, let's see. So we have a negative x value over here and a positive y, and I have a feeling it's going to be negative. Let's double check. All students take calculus. Okay, only sign is positive, which means it will be a negative over here when I plug in for my actual value. So tangent of 29 pi over 6 is going to be negative square root of 3 over 3. Okay, so here's the homework. I hope this was helpful. I'm sorry it's so long. Let me know if you have any questions.